a general engineering contractor, and basically manage our own projects. Again, I think that's something that was a challenge for us, but helped us actually be commercially successful. So rather than try to train a third party EPC company how to build these, we just said, hey, we've been doing it on the pilot scale at our facility. Let's just go build these on a commercial scale. We'll hire all the right subcontractors and tradespeople, but we'll manage the project with our core team. So we expanded out from research and development to, basically a construction team, and now we have operations teams too. So we're actually operating our own facilities. So kind of keeping all those pieces in-house, has been a challenge, but also I think a real key to our success is just the perseverance of keeping, keeping those core competencies in-house and not, at least on the first ones, not farming that out because we had to learn as we go. These aren't plants that, there's already 100 of them in the US and we're just rubber stamping them. It's a brand new technology. So yeah, but that's real brief background. We basically takes us from 2007 up to present day where we've gone from, yeah, researching and patenting and everything like that to actually implementing projects and now operating projects. So
So
What's your,
almost 20 years. Wow.
yeah.
Gary, you had a question there?
well, yeah, I mean, it's a fascinating story. And I know there's a lot of technological innovation you've done there, particularly your indirect approach to doing the electric power generation with a separate cycle. But talk a bit about fundraising. That's a long journey before now you have an operating plant that's presumably profitable. How'd you keep going for those 20 years? Yeah, you obviously had some contracts, but building a commercial plant, that's a different enterprise.
Yeah, 100%. And we basically have been lucky that our financial founder, Peter Paul, um, has stayed committed to the plan for the 20 years. And while my team's been able to raise a lot of grant funds and outside support, that helped through that whole R&D program. We had a lot of funding from different agencies and that type of thing, but we always had to provide, like a 50% match or something. So through the R&D phase, we were West Biofuels was actively investing, in the technology and developing the IP and, getting patents and all of that kind of stuff. So that was supported really by Peter Paul, Mieko Willoughby, and Headland's asset management, which was involved as well. So we were able to stay pretty nimble because they also managed all of the HR and other type things along with some other businesses owned by Peter Paul. So that helped us a bit too, is that we had our, kind of small, nimble team that could be 100% focused on R&D and then on construction and then on operations. But then each individual project, I think one thing that helped us too, each of our project sites is developed as a separate LLC, and so we can bring in investment in those commercial projects separately from West Biofuels. So West Biofuels is still kind of closely held, is the company doing under contract the construction and the operations of these facilities, but the facilities themselves are owned by separate LLC entities that can bring in their own investment, can do USDA loan guarantees and all other kinds of things like that are options for commercial facilities. So I think we've been pretty innovative in the finance structure for these projects as well. And still, so we still kept West Biofuels as the company with all the employees and doing the construction, the operations, all of that kind of stuff. But each of those commercial facilities has its own, ownership structure and that and
And
that.
what kind of
So,
leverage have you had in those facilities in terms of debt and equity? Are you 80% debt financed in the projects going forward commercially?
We're getting closer to that in the newer projects, but I will say this, first forest project here, was brand new and is probably closer to a 50-50 than an 80% debt. But now that we're building some data, this plant's been operating great for a year now, has been regularly hitting a 95% capacity factor. Um, and so now we have some data to back up our pro forma. And I think we're getting, better debt financing options. But when you're the first one out the gate, it's pretty hard to get that kind of finance package. It's helped to have the USDA loan guarantee program, although there's a lot of hurdles to get approved on that. That helps out in bringing in banking partners, and there's some banks that are particularly, adept and at that program. But um, but yeah, I'd say now that we have some performance data, the finance options will get better. We're always struggling with the challenge of will you have feedstock? So we need a low cost biomass feedstock to go in these plants, and so being able to demonstrate that is, and honestly, it's a big part of the cost of operating the plant. One of the purposes of the plant and of the company is to help with forest thinning and preventing forest fires and that type of thing. But we still have to finance the cost of, even though they're doing thinning projects, we still have to finance the cost of chipping it and bringing it into the plant. So that cost ends up being one of our biggest operating costs. So getting everybody comfortable, the investors and the bank with the feedstock reliability is a big part of financing the project.
so
Well,
you
let
guys have, um, I kind of say, always feel like in biomass, a lot of kind of customers or stakeholders that are, critical to being able to deliver, a successful, economic project. Um, which is, you have first the waste that you had just mentioned there. You have to be able to find enough of it. And so you're somewhat of a, waste removal company of that. And then you're also selling, your outputs of energy and, biochar. And then at the same time, you have to really think about where you're placing these in the communities that you're kind of operating in, because many times they're the ones that have to go and apply or work with you on the different type of funding grants and also siting in the communities. I'd like you to talk a little bit about how do you, I guess, manage all these types of customers and business relationships so that you can kind of deliver a successful plant.
Mackenzie, you want to field that one? I'm doing all the talking.
Well, for business relationships, I think when you first start out with feedstock, you had mentioned we have specifically placed each of these facilities in and partnered with communities that are threatened by wildfire risk. And so our first facility that's in the back of Matt's background up in Bernie, they're surrounded by public and private lands. And so we've been able to partner with the Fire Safe Council, the different resource conservation districts in the area, also partnering with CAL FIRE and the U.S. Forest Service to help thin those projects or those properties and lands out there. And they will bring in contract with different feedstock suppliers that chip and thin those areas and haul it to our facility. And then we can use the chips at the facility there. I think when we first started out, we had a few people in mind and a few different properties in mind that we knew were going to be able to provide feedstock. But with these smaller communities, it's also word of mouth and creating those relationships there. We have our staff, our plant manager and director of manufacturing, Brandon Bruning, who now lives in Bernie and has been able to create relationships, and the staff out there gets to know, what projects are nearby, who's going to be thinning different areas. And so it's definitely more community based. And once we create these facilities and, get to know the local community, it's definitely more very much a community service plant. And so everyone's really excited to support not only the plant, but knowing that the plant supports the forested areas around it. So that's for, at least for the feedstock part, that's where those business relations really come in handy.
Do
Mhm.
you pay the feedstock suppliers, or is there a tipping fee that they pay you uh, for
But
the?
every plant will be a little different, kind of depending on the need. But for out in Bernie, we do provide payments for the feedstock suppliers who come and bring wood chips in. There are several different circumstances where PG&E does utility line clearing, or there's just some people doing just protected area cleaning around their homes, and they're able to bring it over without needing to pay a tipping fee. Um, but yeah, we are able to pay our feedstock providers, which is great.
Mhm.
Just
Yeah.
also helping the local community and providing, economy boost in Bernie too.
Well, and let's not overlook, congratulations, 1 year anniversary on a successful commercial operation.
Yeah.
That doesn't happen every time.
Yeah, yeah.
All right. Um, I'll just add too, just relationships early on in a project are super important where you're trying to do siting. So we almost always, I think on all of our forest projects at least, we're kind of invited into the community, which is a a good thing because not everybody can see the benefits of these facilities. So it's good to have a bit of community pull, which has been the case for almost all of our other project sites. We have to work with cities, small rural cities or small rural counties typically for these projects. Attend a lot of, meetings, community meetings, tribal meetings. We've presented the benefits to some tribes that are in the areas where we have the projects, and so we try to get ourselves in the community and communicate about the benefits and, really be listen to community input as best we can. We can't please everybody, but I think for the most part, people come to understand, the threat of forest fires and the need for energy alternatives and that type of thing. So I think we have a pretty convincing story, and then we have to get through things like the California CEQA process and all of that kind of thing for these facilities through conditional use permits with whoever the county or city authority is. And so, the plants somewhat sell themselves in that case because of the benefits you can demonstrate with not doing open burning of thinnings or just looking at the actual forest fire risk reduction. The benefits well outweigh any detriments. And the plants, honestly, this plant's very tall, but our future plants are only 60 feet high. This one's like about 110 feet high. The heat exchangers are higher on it, but we've figured out how to make it a lower profile, and for the most part we're generally in a kind of a forested area, and so the trees kind of mask the plant a little bit and everything. So it's really not a visual nuisance. We control the sound of the equipment so that we don't have sound traveling off the property and being annoying 24/7. So all kinds of things that we've done to kind of make the projects more attractive. And they're not the traditional biomass plants that are big and kind of noisy and perceived as polluting. So I think we're trying to build a different kind of model that fits better, kind of pulls wood chips from a smaller circled so we don't have trucks going all over the place. It's intended to, kind of what I tell people is over the 20-year, utility contract that we have for this project, we plan to have like a 30-mile thinned area around your town. That's kind of what the plant is envisioned to do. It's to help create that fire break essentially for the community, and that's just obviously it's not clear cut. We're talking about just thinning and taking out the understory and the brush and all of the stuff that's built up over all the years of preventing forest fires. By clearing that, we can reduce these catastrophic fires that burn whole towns in the Sierras. So that's
Now,
the concept. So
one thing I kind of heard from there, and I've heard it from other people working on, biomass plants is, well, a lot of times I equate kind of biomass a lot with the forestry industry because it's, you take in the forest and then you put, send out your kind of commodity around it. And over the past, 40 years, my family has been in the forestry industry, a lot of consolidation, a lot of plants working towards economies of scale, going bigger and bigger. And as you mentioned, a lot of biomass plants kind of historically have been like, okay, we need to get the scale, we need to go big. And from my perspective, that's always kind of made it hard to go into the Sierra Nevada foothills because a lot of the all of the regions are kind of looking for a plant that can provide some sort of economic development benefit to their region. So I'm hearing kind of you talk about smaller plants, a 30-mile radius um is it seems like that'd be a lot harder to make work economically, but you have a plant. Do you have a vision of, smaller plants kind of all up and down the Sierra Nevada foothills managing the forest waste on this? Or is this something that, in 20 years we're going to start to see a lot of consolidation happen for economies of scale?
yeah, see there's two economies of scale working against each other in biomass, right? So if I build a giant plant down in Anderson, which there happens to be one, right?
Mhm.
Um, we've got trucks that have to go 150 miles to drop off a load of fairly lightweight biomass to that facility. So that's a cost. It's going to cost diesel fuel and somebody's time and all of that kind of thing. So our vision is these modernized facilities that are low emissions, um, that are closer to where the biomass is. So we're not having all that hauling distance. So we have some savings that occurs, in the entire economy of the process by being closer. But also these plants are pretty automated. We run them in kind of a hub and spoke model. We have our core technical staff here in the Sacramento area, that can go service the plants. And we have a small local crew that operates, each of the facilities. Um, for example, a traditional biomass plant might have, 30 or 40 employees. We at each of our plants we have 10. So on site. So our approach is really, have the plant close to the biomass, don't have a lot of hauling distance, have it actually provide benefits to the electrical grid in the town where the biomass is coming from. We go right into distribution, so we're going right into the community's substation and providing that power, so it doesn't have to be supplied. So we're also avoiding transmission of electricity from somewhere else. So we're relieving, grid congestion because we're producing our megawatts right in that community, and it's getting distributed right into that circuit, that serves a community. So in those ways, I think our model, while not of the conventional logic that you should build it big and that's the right way to go, that doesn't always work with biomass because being closer to it makes a difference. We can be a community asset in the sense that, like Mackenzie said, people can drop off material to us and we'll chip it and use it. so that's a benefit. So they don't have to take it to a landfill or just pile burn it themselves, which happens a lot too, and puts more smoke into the region and that, and that type of thing. So we think the right model is to have these smaller plants sprinkled along the Sierras, and solve the problem that way. We think there's more community integration and a better long-term benefit. There's going to be more effort by the community to keep the plants, operating, and we've already seen that with the plant behind me here in Bernie. We get from all of our suppliers, we get, pretty good attention from them just because they know they can rely on us to take their material.
Yeah, and I think another really big aspect of that too, and just business economics in that in each community is that these facilities require only about 8 operators, 8 to 10 operators to man the facility. One, an inside and an outside operator, so 2 operators at all times. So we have an 8 operator staff. And all of those staff members are from the Bernie community at the Hat Creek plant. So being able to provide good paying jobs in a local community is incredibly beneficial. So not only would having a bigger plant mean more staff, but the being able to focus on good paying jobs in a local community that may not have that upward mobility and just those high skilled positions is really, really helpful for those areas. So that's another big point of having these kind of smaller focused facilities that can focus on the staff as well.
Well, you've spoken several times about you know, more plants coming in the future. Tell us a little bit about the plan you have. And I think you've been taking over some projects that others had started. So what's the future plan?
Yeah, so the Matt, if you want to talk a little bit about the Biomap program, and then we can talk about the projects that are in line there.
Yeah, absolutely. So um, uh, we have about 5 additional project sites that we've been developing through the Biomap program. This was the second plant we built. Actually built the plant for rice hulls as well that operates in Williams. We don't operate that one, but so this was our essentially our second plant. We have 5 more, kind of in the process. Some much further along with their permitting, and all 5 projects do have power purchase contracts. Um, those contracts, our newest contracts, are actually with the Pioneer Community Energy. This plant, the contract's with PG&E, but Pioneer Community Energy is um, is also participating in the Biomap program. So our 5 new contracts are with Pioneer. They're a foothills based, community choice aggregator. And so the partnership with them has been great. But those projects are, anywhere from Quincy all the way down to Mariposa. And the 4 of them are forest projects, and one of them is an ag project. But yeah, they have the contracts. We're working with PG&E on the interconnections and working with the various communities on the use permits that we need to build the facility. So we have sites. We're just going through the pre-development process on each of those projects, and trying to get them all lined up. But go ahead, Mackenzie. Maybe you want to add something to that.
No, I think you outlined it perfectly. We've been able to secure these power purchase agreements or contracts with the utility due to the Biomap feed and tariff program that was supported by the state and the California Public Utility Commission that requires the utilities to procure 250 renewable megawatts of clean energy. And so being able to partner with PG&E with Hat Creek Bioenergy and Pioneer Community Energy at these other plants, we were really able to secure those contracts and then create that renewable energy for those local communities at the community 3 megawatt scale.
Got a good question, I think, actually from the chat from Carson Wilcox. How did the remoteness of Bernie play into the success or challenges of siting it there?
Um, I the in terms of the success, I think, when you go into a place like Bernie, that they don't have a whole lot of business development going on there and that type of thing. And there's a lot of, um, there's closed down forest industry, consolidated forest industry, that type of thing. So it did build a lot of excitement in this small community. We could sense that for sure. Uh, when we got there that, that we were doing something, that we are building something new in the community. So I think in that sense, everybody knew us pretty quick, which, is good and bad, small communities, right? But I think it was mostly good. Um, then, ways that are harder, I guess, with the remoteness of many of our projects is just, this heat exchanger behind me here, hauling that up to Bernie from the port of Oakland, is not the easiest thing. So getting some of our stuff to the project site was a challenge, and then just the kind of hardware we need when we're doing construction isn't something that we can get at Hovis Ace Hardware and Bernie, right? There's some logistical challenge to the construction, but for the most part, we had all of our key subcontractors, I think really enjoyed staying in Bernie. We've got Bernie Falls, a mile away from the plant. Lots of fishing. There was stuff for them to, even though they had to be up there and kind of, they're building the plant. They got enjoyment out of, being in that part of the Sierra slash Cascades, and so that part was good too. But yeah, we managed to do everything we needed to do there. But there's always just a little bit of challenge because you're not quite, in at you don't have Fastenal and all of the hardware suppliers right there. It's going to take a little bit longer. You have to do a little more planning to get everything you need for the construction job.
Do you see any opportunities going farther up the Cascades, Washington, Oregon, with this kind of project, or will you need the kind of support that the Biomat program provides?
I think there's definitely opportunity to get to work on projects in Oregon and further up the Cascades. Um, but it is, I mean, it is going to require negotiating, a power contract, with one of the utilities there. I think the benefits of, having a base load renewable, as well as the obvious benefits of having an outlet for waste wood or that type of thing. I think if you combine all those properly, we can be a pretty cost-effective power source. But the utility that provides the purchase agreement has to agree with that, and then again, it's just again securing the feedstock for the number of years that you need to operate the plant. So we've had some conversations with entities interested in this, further up the Cascades. But again, we've kind of focused on these biomat projects because we built one, been successful with it, know the model, and so I think once we build those out, we're going to look at, well, what are other models that we could be doing. Right now, we're going to be focused on the ones that we have contracted, and then I think we can even do better on our pro forma once we know a little bit more about running these and drive down costs a little bit more. Um, we're seeing wildly different costs for feedstock depending on where you are. In Bernie, we have a very established cost because there has been existing biomass plants in that region, and so they've kind of established, you know, uh, a certain cost structure. But if we go into a community like Mariposa, who's long lost their lumber commercial forest industry, there, we might get free or even, tipping fee for feedstock just because, the current practice is to haul it all the way down to a biomass plant way out of the region. And so, the operators we've talked with there, would have a cost savings even if they could just, dump it off for free to us. So that hasn't quite settled either. It's like, does the thinning project pay for the cost of the biomass, or does the power plant? So all of that is different in different areas, and we're learning that and kind of trying to set a normal price, that again, like I said, the price is kind of a moving target because it's whether the cost of the biomass is part of the thinning project, or is it part of the energy production project. It probably needs to fall somewhere in between, but
Uh,
but
how
that's
much
that's
how
something
much
that we
does
need to establish. Go ahead.
how much does the biochar that you get out of this play into the, economic picture of it? On some of the, reports that, I read that you guys did, it was very optimistic about how much biochar could support the plant operation on things. But, kind of from at least a lot of the other projects that I've seen, they've struggled to find places to, I guess, sell all their biochar or move it into the market at a price that they wanted to. So how much is biochar something that is becoming easy to sell into the market and actually benefiting it, or is it something that, you're really hoping the market develops for?
Well, I mean, it's a little of both. I think at the right price, there's a potentially very large market for biochar, but some of the reports I read, I'm like, yeah, we're not gonna get $1,000 a ton for biochar. That's not a price that's gonna happen. Um,
Delivered.
but right now it's being utilized not too far away from us in the Fall River Valley and some of the agriculture over there, very successfully. Um, and the way we're generate with our partner Pacific Biochar, the way we're generating revenue out of it is establishing its carbon capture capability. So part of monetizing the biochar is its benefits to the soil, but the other part of it is that carbon is going to stay in that soil for hundreds of years, and so that carbon credit that we can generate from that is part of the income. So, but from our perspective, for just rough numbers, for every ton of biomass we put in the plant, it's about 15%, our 0.15 tons of biochar comes out the other end, right? So overall, at a, a volunteer carbon market prices plus the soil benefits and everything like that, you know, compared to the electricity, it might be add, another, again, sort of 15% on the revenue from the plant. So we're still mainly focused on the energy component.
Mhm.
And then the biochar can bring in some additional revenue in terms of those voluntary carbon credits, and then just its benefit to to soil to soils. Yeah.
I want to get to audience questions in a second, but I want to kind of also ask you a question that's a little bit out of, I guess, maybe left field on this. But with all the R&D and the research that you guys have done and experience in it, is there a place for AI or advanced machine learning to fit into, I guess, optimizing these plants, or at least the design and delivery of them?
Oh yeah, 100%. I think like I said, they're very highly censored, very, lots of sensors on this plant, lots of data. We are already thinking about how to use that to kind of optimize the operation. You're using a pretty variable feedstock going into these plants and variable in moisture, variable in particle size, all of that kind of stuff. So making these plants smarter and having them hit the numbers more consistently is something that we're gonna, pursue and try to optimize using some machine learning type of tools. And then honestly, just yeah, the tools are super helpful for we can take all of our project documents for Hat Creek, right, and put them in a LLM and help write the documents that we need for the future projects. So just things like that are a huge. We can have a smaller, nimble team developing projects because we don't have to re-engineer everything. We can kind of reuse some of the same material we've already developed, using AI. So we've already taken an advantage of that in terms of just trying to generate, there's many reports, and I see Fred Tornator on the call here. He's supported us in a lot of the pre-development of the projects at TSS Consultants, and we have to generate reports for the bank, for the Energy Commission that gave us funding, for the Department of Energy, for everyone. So those tools are helping us, do that more efficiently, I think, too, on the front end too. So
All right. Now we have an audience question from Peter, or is it more of a statement?
Actually, it's a couple of questions.
Oh,
So, since I guess you may not know, but Thomas knows that my background is basically power system engineering. So I ask kind of questions about the electric side. So how big is that Bernie plant in megawatts, the output?
it's 3,600 kilowatts gross and 3,000 net, basically.
Oh,
So three
okay.
megawatts.
Oh, okay. So you're connecting to the 12 kV then, the
Yeah.
distribution.
Yep.
Okay, okay. Now, and this is kind of an off the wall question, but so my understanding is Bernie has just a single 60 kV feed in to the city. So if that line goes out, do you have to trip, or does PG&E let you island with some load as like a microgrid?
Super interesting question, actually. So they can switch over to uh, the pit substation.
Right.
And when they do that, we have to take a curtailment. Um, and the reason being is they offered to put the protections on the pit so that we could run in that situation, but it was going to add another, I think, $2 million to the project. And so when we went through the data of how often they do that, maybe it's 5 days over 5 years or something like that. The economics doesn't pencil out to pay for that upgrade. So we look at that on all of our projects. So if there's something going on at the substation, we go down. If they switch to pit, um, then we go down until they finish. And they typically only do that to do some sort of maintenance. So yeah. So we do get in situations with our interconnections. That's one of the biggest challenges to getting our projects going, because we are going into the 12 kV and they got to check everything. And we're a synchronous generator, so they got to be able to trip us, and also make sure that we have the right equipment to sync and all of that kind of stuff. So
Yeah.
so um, so that's one of our bigger challenges. And sometimes we do just say, okay, how often is this scenario going to happen? And if it's not that often, we'll just take curtailment. So far, I think we've had maybe 3 days of curtailment, and that was mainly for a transformer replacement at the Bernie substation.
Okay.
But yeah, so being in distribution, we have to take shutdowns, when, and again, we're sort of on a rural part of the grid, so we
Right.
do have to deal with, oh, somebody ran into the power pole situation and we have to go down. So
Sure.
hopefully the forced fuel cleanup that you guys do reduces at least the power safety shutoffs you might experience.
I hope
Yeah.
so. Yeah.
Yeah. Yeah.
Did
Okay,
you have
great.
another one?
No, I think that's good. Thank you.
Thanks,
All right.
Peter.
But I think that also that question does bring up a good point, Matt, and that the facility does produce about 3 megawatts of power, which powers about around 3,000 homes, which is roughly the size of Bernie. So that kind of goes into what our earlier discussion was on how we partner with these local communities that are seeking, biomass facilities to take their biomass, but not only that, but we're able to produce uh, power that goes straight back into the distribution grid into the community that we're supporting. So it's definitely a closed loop in that way as well.
Is there a world where you might see a town like Bernie become a large microgrid with one of your plants where they can, avoid some of the maybe costly transmission upgrades?
Yeah, potentially. We've kind of danced around that a little bit with doing some microgrid type projects, and especially looking at rural infrastructure like pump stations or water treatment plants, that type of thing where we can supply some continuous baseload power to some community, asset that needs it. So we're starting to look at that, and I think that's a good potential option going forward as these communities get more creative about their power supply. Um, Honestly, I mean, if electric trucks get go off, we could be supplying a truck charging station or that type of thing too. So there's a lot of potential, kind of future off the grid or microgrid type of situations um, that we might be pretty cheap power. We're not perceived as cheap as in the biomat program, but in those scenarios we would be very, very low cost base load power. So
All right, Peter.
Yeah, just one more thing. The reason I was asking some of these questions before, and then we got into the microgrid and the supplying load, is that I've had a number of clients where we were doing the interconnection for them for their project, and the utility, I mean, 100% of them will not let a private party serve their own load in an islanded situation from a non-utility generator because of the liability. So that's why they always put these tripping relays on you so that if the source goes out, you're off too. And so in situations like you were just discussing, it's possible to do it, but you have to do it in a way that you're not serving a utilities customer, you're serving a private customer somehow. Well, and that gets into regulation issues too. So it's technically possible, but there may be regulations that you have to deal with. So it's just something to be aware of, that it might not be as simple as you think. That's all.
yeah, 100%.
All right. So I think we've had a really good discussion today. I don't see any other questions from the audience, but one thing I want you guys kind of to hear kind of from both of you, um, from your work at West Biofuels, you guys started doing R&D on a lot of different parts of, I guess, waste to fuel, starting from 2007 all the way to now. At what point were you like, hey, this sounds like something that we can cobble into a commercially successful project. This is something that, hey, we could go after and deliver what people want with it. And yeah, I guess that was when did you have that kind of aha moment that this is something that could work?
I mean, I don't know if there was like an instantaneous thing, but you know, back in about 2016, 2017, I think we really started looking hard at biomass. It's in our name, fuels, right? We've been focused a lot on liquid fuels and renewable natural gas, and we still are doing a fair amount of R&D on that here, and we have a potential kind of commercial demonstration project with renewable natural gas with Southern California Gas Company. We didn't even talk about that today, but those, you know, we started to see that those are commodities that, well, renewable natural gas, you can get a long-term contract for that. But a lot of the fuels work that we were doing, there's really, those are commodity markets and there's not long-term contracts. And there's just always challenges with trying to finance a commercial project in the liquid fuels arena because A, never been done before, and B, commodity market with, hard to project a 20-year project. So electricity became more attractive mostly um, because we could use the technology, we could make a value-added product, but we could also get a 20-year long-term contract, which is kind of what we needed to get the bank and the investor excited about doing the project. So that was kind of the pull into the electricity realm. Um, and we're trying to replicate that in the natural gas realm too. So we can take a plant like this and instead of making electricity, make synthetic or they call it bio SNG, but synthetic natural gas, renewable natural gas, and put it in the gas pipeline. So we're currently kind of pursuing that with Southern California Gas Company as a future market. But what I've learned, over the years is like we can make a really neat, jet fuel or wax or other types of products, with our gas that comes from biomass. But those markets are a challenge when it comes to actually building a multi-million-dollar facility. All of a sudden you've got to prove that you're going to be able to hit your price point for the next, 20, 30 years, and that's a little bit harder to do. But if you have a nice contract that is that length of time, then that helps you. So that was really the pull. And like when the Biomat program really started going, we were like, we really need to ride this wave, prove that we can do this with electricity, and then maybe we can move into natural gas, and then maybe in the future we can move into liquid fuels.
Mhm. It's coming up to 10 o'clock, but we have two questions from the audience. Can you guys stick around a little bit for those questions?
Sure.
All right. Alec.
Yeah, hey, yeah. First of all, thank you guys so much for giving this talk and for the work you do. I've lived most of my life in Sierra Nevada foothills, and this is super exciting. But the big question I had is, yeah, like, and I think I'm hearing pieces of the answer. How do we scale? What are the next stages to scaling deployment? Because you've spent 20 years, researching, getting to viability, doing these first projects. Now it's like, okay, how do we get dozens of projects going? What do you see as the path forward for that, or the potential blockers there?
Yeah, good question. Yeah, our like I said, our goal is to get these 5 projects we've got in the pipeline out there, and then go the next level instead of we've done 2, you know we're gonna try to do 5, and then we would scale it up to more. But there's nothing. There's nothing about our model of these community scale plants that isn't replicatable. We're none of the equipment behind me can't be, assembled by any competent, mechanical contractor that deals with ASME code and that type of thing. So I think it's highly the model can be replicated quite easily. That yeah, the challenge is just you know permitting. Utility interconnection is a huge barrier. That's like a 18-month delay these days on any of our project sites, and we're lucky we're going into distribution because it's a little faster than trying to go into some of the cluster studies that the utility does. We've been able to avoid that, but that is one of the challenges is, and I think you hear that from a lot of power developers is just interconnection is a challenge. And it's especially a challenge for us because we are a synchronous generator. They tend to not like us the way they like inverter type projects. And I don't mean don't like us, but there's just more scrutiny to the project and that type of thing. So the interconnection barrier and then just community permitting barriers, are things that kind of slow down the deployment. But if you can make the pro forma work, I think this is highly replicatable.
Yeah. And I think another something that we spoke about in a previous podcast as well is that this is new technology in this area and hadn't really been done before, but because of West Biofuels team with Matt's help, we've been able to create this facility, create Hat Creek Bioenergy, and now we have a year of performance to bring to other banks, to bring to other people who are interested in these projects. And so we are proof that it works, proof that these projects are successful. And so being able to replicate that, as Matt said, is much easier now that we have a footprint and a new template to do it. So I think the 20 years or more, the most recent years, 10 years of getting it off the ground is now we're going to be able to keep it rolling a lot faster. So great question, Alec. But yeah, now that we've been able to show our first facility and now this Hat Creek facility is really going to help boost the next few projects, I think a lot quicker than we did the first ones.
That's awesome. Jeff.
Hey, Jeff.
Yes, hi. Thanks for your insights about the liquid fuels production, potential for liquid fuels production. It's a subject that I'm interested in because I think it can really help us to get the excess biomass out of the forests here. And as I'm sure you're aware, there are various different operations, mostly I think in Canada and some in the United States, that are producing liquid fuels, jet fuel from forest biomass. I'm wondering what you think, whether you think the economics of that situation are shifting. Is it moving towards greater viability? 10 years ago, it seems like it wasn't viable at all. The liquid fuels industry is rapidly developing. Are the economics moving towards that becoming more viable?
Yeah, I think so, Jeff. Um, I think the um, there there's been some successes. There's also been some massive invisible failures too. So when you go to a banker and say, look, this is successful, and then they have their technical expert tell them something different, that can be a challenge. Not that we've done that, but I think there's some European and US, very very front and center failures in the liquid fuel biomass to liquid fuels arena. So I think it's still a barrier to get the financing is really the challenge. Technology is always challenging too, but to get the financing and to get the scale that you need. I'm not sure it's totally a model that works for our Sierra Foothills type projects. I mean, again, it would probably be building, these are sort of refinery type facilities. In a sense, you would be hauling biomass from a farther distance. So I think in that sense, we still have this holy grail of building like a small plant that can generate like I don't want to call it biocrude because it's really nice stuff. It's nice wax and pretty much neat diesel fuel. It's like a combination of those. We produce it here at our test facility. Maybe that could be done, and then those materials could be taken to a refinery to be upgraded. But we're still trying to develop that model. But again, the challenge is, who's going to be first out the door and who's going to, get that 5 years worth of data to show that it works. So I think it's getting better. Obviously, the technology is getting better day by day, but I'm not convinced we're there yet, in terms of having biomass to jet fuel plants all over the place. Still going to take a little bit.
All
Yeah,
right.
there's a conference about sustainable aviation fuel up in Tacoma in August, which I plan to attend and get more information. I'll fill you in on what I find out there.
Awesome. Thank you.
Excellent.
Thank you.
Thank you, Jeff. Gary, do you have any final questions or?
No, but just one, gee, it's such a great story. And, you probably never thought it would take as long as it's taken to get where you are now. But you've been blessed by having an investor that has stayed with you on this. And I hope he is having a smile on his face about seeing things operate. But I'm sure he wants to get more plants on the ground and recover more of his investment. But
Yeah.
I think it was really helpful. Of course, this is being live streamed at the same time, and we have people that watch the recording. So I'm sure there'll be other questions, and we may forward some of those to you as people ask them as they view this after the fact. But thanks so much for doing this today. Congratulations on all your successes. Look forward to more. And maybe you'll get a bigger office there in Woodland. Getting a little tight, I would imagine.
All right. And I think with that, Matt, Mackenzie, thank you both. This is exactly what we built Clean Start Perspectives for, the conversations that we want to have, not just talking about the technology, but also building the business here in California and how you guys are facing the stubborn problems and overcoming them. That's really what Clean Start's here to help companies get over and accelerate the energy transition, turning risk into opportunity. So I appreciate you sharing your time with us today and your story. I want to make sure that we thank our supporters, SMUD, Chico Start, the Carlson Center, and E2. You can find us at chicostart. Or at cleanstart.org. You can find West Biofuels at westbiofuels.com. And I put a link in there to another podcast that they were on that I thought was really cool, NorCal Rocks. You can follow us on LinkedIn and YouTube, where you can get plugged into what's happening in clean energy entrepreneurship in the greater Sacramento region. So a big shout out to everyone who joined us today. And we will have a recording of this, as Gary mentioned, up on our YouTube channel. It'll be slightly edited. And that's a wrap on today's perspectives. Thank you, everyone, for being here. Hopefully see you next time.
Thanks, Thomas.
Thank you.
All right. Thanks so much. All right. Bye-bye.
All right, let's stop recording, stop the stream.
Well, we got some good,
We're still streaming live.
yeah.